Director of DIA-COE, IIT Jodhpur, and I am really thankful to organizer of Icon Bharat for giving me this opportunity to speak to you on this session talk on the topic Journey of Metals from Vedic Age to Modern Day. I am really grateful to Vedarshi ABS, who is the founder and director of SRIVT, and he is doing the commendable job, modern day technology, to bring out certain useful things and the ancient for the benefit of humankind for using the modern day technology. My topic, modern day, is a topic which bridges the ancient. We see the history of existence of human being on this planet Earth. We see that for millions of years, human being was another animal who is dwelling in the forest and barely surviving. But around 10,000 years back, when he started using copper and bronze, 3000 BC, he has started using iron. The metal has started playing as a very useful friend of human being, so that he can fight with the animals, with the enemies. He can using the metallic tools. So metal has played a very useful role in human civilization. In fact, we were the leader. If you see our ancient texts, Rig Veda and later Vedas, Rayamitra, Nagarjuna, Bhagbhatta, very vivid descriptions of metals is there. In fact, in the mentions of 8 metals is there. If you see the copper metallurgy in ancient India, it has started with Harappan civilization, and we were aware about how to extract copper from the ore, zinc and made brass, and we were aware about shaping of copper or bronze into different shapes by forging, sinking, raising, cold work, annealing, riveting, lapping and joining. Harappan's objects discovered are spearheads, arrowheads, axes, chisels, sickles, blades, needles, hooks and vessels such as jars, pots and pans. Harappan also used gold and silver to produce a wide variety of ornaments such as pendants, bangles, beads, rings or necklace parts. So in the classical age, copper bronze smiths supplied countless pieces of art like huge bronze statue of Buddha made between 500 and 700 CE in Sultanganj in Bihar using lost wax technique. We were out the gold, silver metal. Mainly it was used as an ornaments, jewelry, and in Karnataka, in Maski region, it is the oldest mine, the mid-first millennium BC. And we were the master of iron metallurgy in ancient India. The Ganges civilization, which emerged, Vedic text mentions of a dark metal, while earliest texts such as the Rig Veda only spoke of ice, which it is now accepted referred to copper or bronze. In fact, the wood is from India, and we were master of making it, and it is basically iron containing a high proportion of carbon. And India was a major innovator wood steel, which was used to make the swords, and it was produced in South India from about 300 BC. And second advanced iron is the one used in the Delhi iron pillar, which consists of about 6 tons of wrought iron. And it is this technology that, in spite of around 1600 years of exposure to the weather, it has not rusted. We were also the innovator in zinc metallurgy, and we were the first to produce the zinc in the reverse distillation process. And in the Jawar region of Rajasthan, we have got these references. These are the dancing girls found in the Indus Valley civilization, made up of bronze, and these are significant. Casting technique has been used, which is currently also being used to produce the complex processes. So we were aware about this process. We can receive uh, hundreds of such type of artifacts, statues, which were produced by the ancient Indians, and casting techniques where the mold was prepared by the wax, and then it was by melting it, we were taking it out and then casting the metals and cooling and finishing it. These are the statues. We were also aware about the gilding process, that is how to coat these bronze statues or copper statues using the mercury amalgam applications. These are some of the monuments which have been uh, recovered in the archaeological excavations, Jagannath temples, and the Damask sword made in the medieval India. These are the retorts found in the mines. These are around 3000 years old, and they were used to produce zinc in ancient India. The mention in our texts are there about 8 metallic ores: Abrak, Vikrantmadi, Sonamaki, Vimla, Shilajit, Neelathota, to take out metals, different metals. What are the processes used by the ancient Indians to prepare the iron pillars and other by instruments described in Rashtatnakar? Around 34 instruments are there, and there how to make these instruments and how to use them in various metallurgical processes. Now, for 3000 years, the knowledge was first around 17th, 18th, and 19th century in Europe. A quantum revolution took place, and many metals were discovered like aluminum, titanium, uranium, tungsten, and I will cover them in my next slides. And the metallurgy, what was a tradition and art in ancient world, has been converted into science and technology. At that time, various industrial processes for bulk production has been uh, developed, like blast furnaces and other furnaces, railways, household and agriculture equipments has been taking place. The most important discovery in medieval time was the discovery of aluminium, which is where the earth crust. In the ancient time, the knowledge of how to extract it, how to reduce it, was not there because it cannot be reduced. In the it was discovered by Danish scientist, and then in 1886 the Hall process has been developed to separate this metal from oxygen, uh, and abundant in earth, and it's the light metal. And if you see the strength versus density ratio, the specific strength, it has very high strength, and these finds very wide application in aerospace, and as a foils, as a wire drawing, as a corrosion resistance, and in other various other, and replacing many applications of iron and steel. The other important discovery was that of titanium. Again, this is very highly abundant in nature, and in strength wise, it is competing with the steels, and density wise, it is lighter than steels, and in many processes, it is again replacing, and but it is slightly costlier today's, and we hope that by that time, its cost will come down. This metal will find very large application in aerospace, as well as chemical reactors and things, and for storing hydrogen and oxygen. Titanium is used in rocket engines and other components. Titanium has a potential application in fields like medicine, marine engineering, and electronics, and shape is being remembered by the metal, and if you it will again take the shapes, so it can be used as a future construction material in the space where the normal processes cannot be used. The other materials are chromium, which is used as and stainless steels are produced with this, and ferrochrome alloy is a key ingredient in stainless steel. Then there are other of chromium, especially in the high temperature materials, and then high corrosion resistance materials. Humankinds, and using the vanadium, we are producing various kinds of steel alloys, and it is being utilized for essential catalyst. And main use of this is as an alloying element. And head filled steel is one of the application where this rail track are fabricated using these metals. It is highly damping in nature of vibrations, and it is very hard and tough. So it is being utilized in where the application where you require very high hardness, like jaw crusher, etc., etc. Application in reactors, nuclear reactors, as well as an alloying elements and superconductors. Cobalt is another element which has been discovered. This element is finding very high applications. It is being utilized in magnetic materials and various other applications. Nickel is another metal which is used mainly for coatings and platings, especially monal, nichrome, thermal silver, steels, and nickel-based alloys in thermocouples, inconel, nickel titanium alloys, sap memory alloys. So this is highly useful. It has been again discovered in 1750 by Swedish chemist. Zirconium. These are the material used in nuclear applications and medical, surgical instruments, dental implants, electronics, and many other modern day applications. Useful applications. It has been discovered in 1778, and applications are there to improve the strength, hardness, and wear resistance and air resistance of steel. These are used in photochromic glasses to control light transmission, catalyst in petroleum refining. Alloys containing molybdenum exhibit excellent acid resistance, so these are used as a reactor construction materials in chemical industries. Per view, because it is the lightest element, lightest metal on the earth, and some of its alloys are even lighter than the water. Very useful metal for batteries, and its application is increasing day by day, but it is not available in plenty. So how to get this element is a question mark. Probably the space mining can help us. And lithium has another application in the as a radioisotopes in nuclear reactors, lithium 6 fusion reactions, and also as a nuclear neutron detector. Another metal of importance for nuclear application is beryllium, rocketry, nuclear industry, electronics, and other refractory as a refractory material. Magnesium is another metal. It is the brother of aluminum, and magnesium is very useful. Many other metals are of importance. So, and its alloys with aluminum are being utilized in the aero applications as they are heated, and in the density ratio they are competitive. They are better than the steel components. Tungsten is another metal which is of importance to defense applications, and so finding out its ores and these things is a challenge, and future research is focused on these things. It is used in the cutting tools. Whites are the hardest material on the and used in the high speed cuttings, and various other applications, especially in the defense, like armors, nuclear fuel. And it is a metal which is highly controlled in this in the world, and this is used as a nuclear fuel as well as the radiation shielding and nuclear weapon. It is the strategic element which is controlled by uh, different international treaties. Production of metals which has been used during the medieval times, and it has changed the ancient art of the blast furnace, open arc furnace, Bessemer converter, LD converter for steel making, electric furnace, electron beam furnace, rolling mills, hydraulic presses for forgings and extrusion. Coming to the modern day metallurgy science and engineering, which is the extension of medieval metallurgy. Various alloys I have discussed with you, which are finding various applications now in the modern day in the missiles, submarines, nuclear, electronics, medicines, robotics, radars, and automobiles. And we have also developed electron microscope and XRD studies. And the physical metallurgy has been started, where the phase diagrams and microstructure properties relations has been established. Now, depending upon the applications, we can develop an alloy. In fact, we can design an alloy and we can simulate its properties, and then we can develop it. So current status, if we see the metals and alloys, there are iron carbon alloy systems where the steels are there and carbon cast irons are there, then alloy steels are there, and other than the iron carbon steels, we have non-ferrous materials like aluminum, chromium, copper, magnesium, nickel, zinc, and silicon. We have stainless steels, particularly are used where resistance to corrosion is important. Aluminum alloys and magnesium alloys are commonly used when a lightweight strong part is required, such as in and for non-magnetic application. Nickel-based super alloys like Inconel are used in high temperature applications, just such as gas turbine, turbocharges, pressure vessels, and heat exchangers for extremely high temperature. And single crystal alloys are used to minimize creep. In modern electronics, high purity single crystal silicon is essential for metal oxide silicon transistors and integrated circuits. Nanomaterials by reducing the size of the metal to a nano size, various innovative properties are developed and being developed for application in robotics and space construction. We also have converted metallurgy now into a material science and engineering, where various composites have also been developed which have replaced metals into various applications, especially the aerospace applications. And we are now using the computer and softwares for alloy designing and simulations. And we also working for, if you see the modern metalworking processes, casting, forging, rolling, extrusion, machining, sintering, fabrication by gas cuttings, and many more. So basically, and we are also have mastered the heat treatment processes, wherein by changing the microstructures, by giving its different thermomechanical treatments, we precipitation hardening, annealing, quenching, tempering, and in surface treatments, carbonizing and nitriding are very well established process. Improvement, thermal spraying using HVOF, plasma spray, flame spray, arc spray, and metallizing, electroplating and electroless deposition for surface treatments are there. So metallurgy has moved from a very raw application like a copper form available in the meteorite to a well-defined way, extracting metals from ores, making its alloy in various processes, and then giving it various treatments to have the desired properties. Now I will cover some part of my work which I have done for defense. These are the chaff materials. So when the engaged by a missile, it gets a signal, and to safeguard itself, it emits very fine metal fibers called the microwave dipoles, and millions and billions of these dipoles are ejected by the aircraft. That it has it becomes like a pseudo aircraft. In the radar, it is seen as it is giving more signal than the actual aircraft, so missile get diverted to it and it gets survive. Apps, and not only we have developed a very good materials which is better than the imported materials, but we have developed testing. It is found that it is very highly useful. These are the processes we have used, innovative process by dissolving. uh, we can reduce that 10 micron diameter to less than 25 micron diameter in a single pass, and multiple fibers passed in. So by this technology we have established a plant facility producing around 10 lakh meter per day, and this is successful technology where aluminum wire dia of 125 micron is passed through the chemical bath, and then a surface treatment process given to its color. And these are the property have been, you can see when these are tested in a microwave RCS monitoring facility. DLJ developed giving more than 30 to 40% more than the conventional chaff which is imported in nature. So this is what I want to cover, that metallurgy and metals have proved a very useful fertilization, and its use is going to be continued in different. And I thank the conference again for giving me a chance to speak to you, and thank you very much.